Good morning, everybody. I'm going to go on for about an hour and a half now, just before lunch, on talking about the sounding selection programs in HYPACK. These are the standard HYPACK software, mostly intended for single beam data, but can be used for, in addition to multi-beam data and so on. In case if you're looking for the patch testing, that's in the big room with Mike Kalmbach, or Tin Model in the other room here with Jerry. If you're looking for those, you're on the wrong plane. So, but I'll start running through the presentation. So, okay. Just an introduction to it. The sounding selection programs are there's 4 different routines in HYPACK. Allow the user to reduce the density of data sets without really affecting the accuracy of the results. And said, when you collect your data, the more data you collect, you always have to somehow thin it out to something. So you have a single beam data set where you're collecting one sounding every 1 or 2 feet or so, depending on the speed of your echo sounder. You can't plot that. It's just going to look like a big blob like you're seeing over here on the screen. Good luck reading all those numbers. So, a lot of times your CAD guy will be like, that's just way too many soundings for my CAD program or something too. So you got to have a way of thinning out the data, give you the best representation of your surface, like we see over here on the screen. There's like I said, a lot of times the CAD programs can't handle the larger data sets. Plotting, it looks like a big, ink spot. And then when you're contouring too, you get much better looking contours. When you use a dense data set like that, you get a lot of little jagged edges and stuff like that that just, they don't look good as far as, drawing contours on a screen, plotting, or bringing them up in an E&C chart. Usually when you thin it out a data set, you get much smoother contours. Okay. And like I said before, there are 4 different routines. I'll run through each one here, and hopefully have you out before early enough to beat everybody else at the lunch line. So, the most popular one is probably the Soar program, most common. Works with edited HYPACK data. It also works with regular XYZ data, and it's designed to output the show-less depth in your data set, within a specific range. And it always gets saved out to an XYZ file. So you can take that and give that right to your CAD guy, or bring it to a GIS program if necessary, or run through all other HYPACK programs. The cross sort is designed to take your singling data and maybe in a bunch of cross lines and give priority to one or the other. So wherever the intersections are, it's prioritizing either the your cross-sectional lines or your check lines. This gets output to an all format file, basically the same as our format as our single beam edited data, but it's a reduced data set. Just makes it look a lot better in terms of the drawing on a screen. It doesn't give you any priority as to show list or median depth or anything like that. It just fits the soundings as close as possible without them overriding each other. SB selection came along a few years ago. We had a function in the old single beam editor called pre-sort, and it's not really a good way of thinning out your data. A lot of times you want to have a nice even increment, maybe 25 foot soundings every 25 feet or so. The idea of this program is you take your edited data in there, and you can visually see which soundings you're saving. You set a distance there. It'll highlight the soundings that say every 25 feet, and then you can look at all the additional soundings. If you find that there's a shoaler one, another foot away or something, you could ignore that the deeper one and choose the shoaler. So I'll run through that one a little bit too. And then Mapper is a binning program, mostly designed for multi-beam. Big, large XYZ data sets that you want to kind of thin and say the soundings based on min-max, median, closest to cell center, and so on. So I'll run through that one too. Okay, these are all under the menu. Let me see if we have HYPACK here. So to run the Soar program, you go under the processing drop-down menu, you see where it says sounding selection. You got cross-sort mapper, SB selection, and we'll start with sort. Okay. I'm in a single beam project over here, and let me just run through a couple of presentations just so give you a little bit of an idea. Okay. So again, the idea of the way the sort program works, selects the show list soundings, eliminates the depths that would overwrite them. The idea is that it basically takes the entire data set, looks for the minimum sounding in the entire data set, generates a radius around that, and eliminates all the points except for that show list sounding. And then it looks for the next one and so on until you run through the data set. And there's a couple different methods of doing this and a couple variations of it, which I'll show also. It's mostly intended for single beam data. You could use it with multi-beam data, but it's a really long process. There's a tool in there where it sorts based on partitions, which speeds up large data sets, but it's still a relatively slow tool to do it. Some people still swear by it. Port of London over in the UK, they take a multi-beam data set, they run it through the Soar program. They like the way it sorts when they do their charting, and they'll let it run overnight, because it's a huge data set, and the methodology internally, it just takes a long time, but it does a really good job. So again, it's really a good tool for plotting your soundings, contouring, and exporting in CAD. Again, you can take your edited single beam files or any standard XYZ file and load that into the Soar program. The final output is in XYZ. Okay, so let me run through it. Go. Okay, so when you run the program, it lists all the sortable files. So if you have edited, single beam data, or I think you can even load in HS2 multi-beam data if you want. You can load up the HS2 single beam files also. And then if you have any XYZ files in your sorted directory that you want to do, you just enable and disable the files as you do in the main HYPACK shell. Enable the ones that you want to have sorted. So in this case, in this project, I only happen to have a edited log file with about 10 or 12 line files. Okay, so all I would just do is enable the file that I want to sort. Now I have a couple options here. You have a radius, and then you have this other checkbox here for you can enter a delta X and delta Y. So in other words, you can basically create a rectangular area. So if you have, for example, magnetometer data and you want to sort the data, it's like 5, 6, 7 values, like 45,000, 50,000 or something. And you want to have a greater sort distance on the x-axis versus the y-axis, so so it's not overwriting, on the screen. So you can do that also. But the most common is just using the radius value, and that usually works the best. Okay. There's an option here called three-dimensional sort. Basically, the sort program works on a horizontal axis, and it's just looking at that distance. The three-dimensional sort also takes into account the z-value. So if you have some sort of features that you want to highlight a little bit more, give that a try. It'll give you a better representation of that feature. Otherwise, it might, with the standard sort, it might skip over it. Not skip over it, but it'll highlight the show list part, but you won't get a good representation of that feature. So that's available if you want to use it. You have an option for dual frequency echo sounders. You can choose the depth 1 or depth 2. Typically depth 1 is going to be the high frequency, depth 2 will be the low frequency. There's also this option here, depth or elevation, which is really important because it's making the assumption that you're working where your z-value is positive down. So when you're editing the data, it's going to save your show list value. If you're editing data with a negative z-axis, it's making the assumption that in HYPACK negative is going up, so it's actually going to save your deepest value. And I've been on a job years ago where the contractor and the other company, their volumes weren't matching, and it turned out the contractor was inverting their data to elevations and then sorting it. So there was a good half a foot difference between the two data sets. We were able to sort that out. So that's when we actually put this option in to work in depth or elevation data. You have a checkbox here for negate output z value. So again, HYPACK having the positive down convention, AutoCAD likes the negative down convention. So if you want to, save out an XYZ file there and import to CAD, you can just check that box. It's all it automatically going to invert the final data set. So a lot of different little tools there. Okay, the most common option, or by default, I believe, is this sort with no priority. And that's the standard sort that I had described before, where just takes that sounding, generates a radius around and runs through the entire data set. It's slow, but it does a really good job. So we'll start off with that one. So I've got that checked. I think we're good here with everything. Then we have the output option here, where we give the output file a name. So we'll call that sorts. Okay. You have a few other options. One output file per input file. So if you have 10 single beam files, it's going to save 10 different XYZ files. There's one for golden soundings, a little tool that we have where it'll save what we call the golden soundings. You also have an option if you want to save the data that's rejected into a separate file. Say you might want to import the rejected data as an overlay in CAD or some other package, just to compare what had been saved and what had been rejected. So you have that option. By just check that box, give it a name, and you're all set. Okay, so if I click on the sort button, this method runs through two different passes. Everybody see this? It's probably a little bit fuzzy here, or close enough. About 19,000 soundings here. It ended up saving 300. And then what it does, it runs through a second pass just to verify that it's got everything within that specified radius. Okay, so in this case, it's saving 1.7% of those soundings. So if I look on the screen here where I'm drawing all my soundings, I did also with depth 1. Let's disable that. And there's my soundings. Now you see that there are some gaps in here. That's just the nature of the sorting routine. That's not going to be an exact 25 feet or whatever value I've had in there. There are going to be spaces because there might be something within those, like this might have been shoulder. They removed all this stuff. This might have been the shoulder in that same radius, so they removed whatever was in here. So that's just the nature of how the Soar program works. It's not going to be, an exact distance, but it does a really good job of sorting, cleaning up your data, thinning out your data. Okay. There's another one here. This is an old slide here. Maybe I should just bring up the program. Okay. Down below here, sort with partitions. It basically does the same methodology, but it subdivides your data set into multiple partitions and runs those separately. It's quicker with a really large data set. What we did a number of years ago, about 10 years ago, we replaced the initial sort program with that. And it worked great for really large data sets, but it was slow as hell on a single beam data set. Like what I just did there in a couple seconds, it probably took almost a minute, and it really annoyed a lot of customers. So we ended up giving an option to choose one or the other. And then as we went along, we added a few additional options. So like I said, the sort with partitions, it seems like it's really slower on small data sets, but it works much faster on really large data sets. Go figure. Okay. There's another option, sort with priority. So say I had a couple different files that I want to sort over here. I can actually, let's just say that there are two different surveys, the first two or whatever. I can prioritize one of these. By checking that box, you'll see it'll highlight in red. That means those soundings will be prioritized over the other data set. You might have you might have had some weird fluctuations with tide or something like that, or a heave issue or something with your one survey over the other. So you can prioritize one data set and have those soundings saved over the other ones. So that's a nice little tool to have. And then this other one is sort with CHN priority, where I would load an advanced channel file. If you're not familiar with an advanced channel file, it's basically a 3D surface. I'll show you here. I've got one in here. It's the channel file. That's created in our advanced channel design program. So I look at the 3D, basically a 3D representation of the channel. And what it's doing, expand that a little bit. Wrong window. There we go. It's looking at the program is looking for the soundings within the center of the channel, and it's going to prioritize those versus the ones that are what do you call it, along the slope. So normally, like I said, sort works based on a 2D surface. So you most likely would have a shoulder sounding somewhere over here when you actually want to save the one that's within the channel. So just a good way of another way of thinning out your data, giving you another option. Yeah, here's a good example. You can see the bottom of the channel and the slope. So if you got a shallower shoulder sounding here, right on the slope, inside the toe, is the sounding that you actually want to save. So if you choose that sort with CHN priority, that's what you're going to get. So I think we got them all. Okay. And like I mentioned, this is a good example of the 3D, three-dimensional sort, where a little hard to see the dark screen over here. But with a 2D sort, you can see that you've got some actual structures in here. It looks like the bottom of a dam or something. And you're not really getting a good representation of those structures. But if you look at the one over here, it's a little hard to see in this screen, but you definitely can actually visualize those structures. So if you're looking more for that rather than actually thinning out an exact distance, try the three-dimensional. It'll give you pretty good. It'll do a good job for you. Any questions on the sort program? So again, that's all saved in the. It's XYZ data that gets saved, and that just gets saved right in the sort folder. There we go. Keep hitting the wrong button. Let's try that. Okay. The next one is the cross sort program, and like I said earlier, it was initially designed to give priority to either your cross-sectional lines or your check lines, your longitudinal lines, and you could give priority to either one. So you're not going to get this bleeding across these the intersections over here. So you'll be able to read those soundings. And also, again, it's not giving any bias towards minimum sounding or anything. It takes the soundings and puts them as close to each other without them overriding. And the way it does it is that it also requires a plotting sheet from HYPACK. So you got to create that in your plotting sheet editor. The reason being is that it's using the scale of the plotting sheet and also the length and the width to determine which ones are cross lines, which ones are longitudinal lines. And then with the scale, you in the program you enter a sounding size, and it's using all that in order to pack the soundings as close as possible without them overriding. And like I said, there is no priority, so you might have a couple sounding, but you might have a shoulder sounding in that area. So it's something that you want to just be concerned about before you actually use it. But it works pretty well. A lot of people liked it and also wanted to do the same thing with just it'll work without having the cross-check lines too. A lot of people do like the way it packs the soundings close to each other, so they do not necessarily want to have the cross-check lines on there too. So it'll work with one data set too. This is looking again for single beam data, edited data. It won't work with I don't think, no, it won't work with XYZ data or anything like that. And it also requires a plotting sheet. Like I said, you could use one log file, or you could use two if you want to load up the cross-sectional lines too. Your final result is going to be an edited HYPACK file. What's nice about that is that you can plot the data based in HYPLOT because it has your heading information. You can plot everything perpendicular or parallel to your plan line. So that's why we save it in the edited all format. So this is what the program looks like. Right at the top here, you've got an option for either the priority would be the cross lines or the longitudinal lines. You have the depth option that you want to use. It is only going to save one depth to these files. The sounding size, by default, for most charting, is about 2 millimeters for your sounding size. You can play around with that value if you want to have more sparser data. You can put a larger sounding size in there, and it's going to use that to increase the spacing of your data. And then the resolution option here, this also affects kind of how close they're packed. High resolution puts them a little bit tighter. I think there's a percentage or something of resolution. So if I choose low resolution, they're going to space them even further apart. I don't know. I know it works based on a percent, but I couldn't tell you exactly how it is. So over here, we're going to add our plotting sheet file. If you have one data set, you just a bunch of cross-sectional lines, just load those here. If you do have your check lines, you can load them at the bottom. So in this example, I think I was using this project. Oh no, I got another project, sample cross-check. Sounding selection? Yeah, there we go. All right, so here we have two different data sets. We have our check lines, and then we have our cross-sectional lines, our edited files. Okay. Like I said earlier, you also have to create a plotting sheet. If you don't know how to create a plotting sheet, you can go under Preparation, Editors, Plotting Sheet Editor. And basically what you got here, if you're not too familiar with it, you get a little rectangle drawn on the screen. You can kind of move it around with your lower left-hand corner. You can rotate it with the opposite corner. And then you can size it, and you'll see the numbers change on the screen over here for the height and the width. Okay, so you can make those adjustments. And then there's a whole bunch of predefined sizes. If I go under Edit, Predefined, you go to ANSI, you have your A, B, C, D, E, F size sheets. So you can pick that, and it's going to size those accordingly. And then, of course, you have the scale listed over here. I had already created a sheet here. I did an ANSI D at 40 feet per inch. Okay. So the idea is that it's going to plot, based on the scale, everything is going to plot the soundings as close as possible with that respect. So, do I have the program open? I guess not. Okay, go into Processing, Sounding Selection, Cross Sort. Okay. I'll give priority to the cross-sectional lines. We'll use depth 1. I'll make this low resolution, see what happens. I think it's going to space them a little bit more. I'll load up my plotting sheet. My cross-sectional lines are the EDT log file. And my longitudinal lines are the check lines log. Just hit the sort button. Those soundings to my edited folder here. So I can enable those on the screen. And it looks like I'm just drawing sounding points. Let me go to my sounding style. Let's do decimal point on mark. And then you see, if you compare that to my original edited soundings, why is it not drawing there? What if I copied them from the wrong folder here? But you'll see that I selected the low resolution, and it looks like it spaced the soundings a bit further apart. And then I've got priority to my, those are my cross lines, I believe. And again, that's also depending on which way you have your plotting sheet. You know, the length would be the longitudinal lines, the width would be the cross-sectional lines. Let's try that again. Let's see what happens if I do the high resolution. Sounding selection, sort, cross-sort again. We use the same plotting sheet. And my check lines. And let's try high resolution. Click on OK. Close out. Yeah, it looks like you put it a little bit closer. But I'm all set to, I think I have my sounding style as vector on the screen. I go to fonts. Yeah. Normal viewing here. But if I go to the vector soundings, you'll see that, you know, if I choose a 2 millimeter size at a 40 feet per inch, this is going to be a better representation of what my plotting sheet is going to look like. My plot, you know, before I actually set it to high plot, or if I want to export it out to CAD or something. All right, so I think that's it for the Soar program. Okay. The third one is the SB selection program. Like I mentioned, in the old SB Max, we had the pre-Soar program, and this sort of replaces it. We're going to add eventually we're going to add a pre-sort feature to the SB Max 64, but it would act more like a filter. So you can actually filter out the soundings pre-sort, but you can also view them and undelete or delete additional ones if you want. But this program actually works really good for this case, where you want to have a preset sounding distance on the screen. Works really good for plotting, you know. But again, it's not prioritizing anything. But it gives you the option to manually pick soundings if you choose so. So, yeah, there's two different methods. There's by distance, where you put in a distance along here, and it's going to highlight the ones that the program selects by distance. And then there's also this one min-max, where it looks for inflection depth. So you put a depth threshold in here. I think it's a 1, you know, in this example or whatever, and that's looking above and below that threshold from the start for the inflection points, and it's going to pick and choose. I don't know if anybody really has much use for it, but it's available in there if you want to use it. It might give you additional points that you might want to add to your plot, so sometimes it comes in handy. And then the third, there's the min-max, where you can actually do both. We have the inflection points, and you do have the distance also, the fill distance. So you'll have a few extra ones here that you can pick and choose from. Okay, so save sounding based on distance along the line. There's different options here. Min-max and the fill distance is where you select that. Just a few display, whether you display it based on DBL, which is distance from the beginning of the line. The depth, where you can zoom in based on the depth, or both. It basically works with your scrolling mouse. Okay. Again, this is also looking for single beam edited HYPACK data, and the output will also be single beam output data. That's pretty much it. I'll give a couple of examples. Okay, I'll show you the program. So processing, sounding selection, and SB selection. Okay, I'll load up. Is this the project I want? You know what? I want to go back to sample single beam, I think. Yeah. So let's go to this project. I'll go sounding selection. We have a better looking the channel inside there, so I think this project works a little bit better. Click on open. It's going to take me to my edited folder. I load up my log file. Increase this to about 55. Okay. So now I'm seeing the sounding being drawn on the screen. I can look at depth 1 or I can look at depth 2. Okay. So I have my options over here on the left-hand side. I'll set my distance. I'll leave it set to 25 feet. So what I could do is go down here. It gives me the option to apply this to just one file, or if I check the box, it'll apply to my entire data set. So I click on Apply Settings. It's going to highlight. You'll see it highlighted in red along the screen here. And it chooses that. So if I scroll through my files, you can kind of get an idea of which ones are going to be selected and saved. Okay. If I want to go back, let me go back to the first one here. And I have a couple, well, it's below the channel anyway, but just say I wanted to save the shoulder sounding here, like object type detection or something. What I could do is, there's a little button right here. It says Select Sounds. If I click on that and go down here, you'll see I could go in there and highlight that. I might want to highlight that and then maybe remove these deeper sounding. So I can click on the button right next to it, undo selection, and then it's going to ignore those and just save those. Okay, so that's one way of doing it. Okay, the min-max, like I said, is the depth threshold. So if I put let's put a 1 in here, click on Apply, and you'll see it's just relatively flat bottom here. But you'll see it looks like we've got a couple spikes in here too, but it's highlighting those inflection points. So I can again maybe ignore one of those. But I can, in addition to the min-max, I could click on the fill distance and do that in addition to the 25-foot range that I had before. So click on that. I got my inflection points over here. And again, I could use this tool to ignore a couple of them if I want to save those to the file. Pretty straightforward. I think we got them all. You'll see I'm using my scrolling mouse here. I have my scale change here based on the DBL, distance from the beginning of the line. So the scale is changing horizontally. If I do the depth, it'll work vertically or both. It'll just work as a normal zoom. Okay. Draw a template. Elevation mode would just flip it upside down. So if I did my data, edited my data in elevation mode, I can just click on that box and it'll invert the data properly for your editing. So when I'm done, well, let me go back to I like the distance mode here. Apply, and then just hit the save button. Yeah, we'll just call that. And just save it. Close that. Close the wrong button. Wrong program here. One more time. Here we go. Okay, so there's my edited data. And there's the soundings every 25 feet. So you'll see you got the nice even soundings going across the channel. If you're looking more for that rather than the Soar program. But again, it's not prioritizing or choosing the shoulder sounding. It's using just based on distance. So that's another option here. Any questions on that? Okay, we'll keep going. That's the case. We'll be in the lunch line early, I think. Okay, the last one is Mapper. And as I said earlier, Mapper is basically a bidding program. It's kind of designed to take a pretty large XYZ data set and then give you a sounding every preset distance, maybe a grid-based type distance. And it's basically taking the grid and kind of checking out all the soundings within that grid and picking the minimum value, maximum value, median. You can save whichever you want. You know, there's quite a few different options in here, and I'll show you a few of those. Okay. Oh, kind of tells you right here. So what it does require, it requires you to create a matrix file, and a matrix file is basically just a rectangle with a user-specified grid size in there. So an example, I might have a pretty large multi-beam data set. I want to save a 2x2 grid. So each, as we see here, each cell, matrix cell, will have quite a few different soundings in here. So I can go in here and pick and choose whichever one I want: average, closest to cell center, min, max, and so on. Average, beam closest to the user input beam angle, and also you can output number of samples per cell. Sometimes a job might require you have to have I don't know, 3 soundings every 3x3 area or something like that. So you can do that. Just verify that you have complete coverage. So again, first thing it requires is a matrix file, and then you can load in practically any type of data. It could be multi-beam, HS2, or HS2X from HYPACK, anybody's XYZ data, a log file of single beam data you can use, and you have a couple outputs. The main result is typically you're going to output to an XYZ file. You could also output a filled matrix file if you want to display that or plot it in HYPLOT or use it as a dredge pack type matrix. You can do that also. Note here that everything you do here in Mapper, you can pretty much do in MBMax 64. The thing is that MBMax 64 requires a high sweep license, but Mapper is a standard part of HYPACK. So it's kind of a nice tool to have if you happen to have a large data set, you want a multi-beam data set, you want to run through the program, thin out and everything. A good tool to use. Okay, so when you load up the data set, again, you have this little sounding grid options where you can select whatever you want. Again, minimum, maximum. The range is the difference between min-max per cell. You can do the average nearest the cell center. Strikes, I'll show what that is in a second, and also best angle based on your multi-beam. So if you chose that, you would just enter everything within a specific amount of degrees from nadir. Okay. Also count, and also the sum of values. Not really sure what the reasoning was there, but somebody must have requested at one time. Couple positioning options. It'll use the actual XY when possible, or it'll just move that sounding to the center. If you're looking for a nice even grid, you would just choose that option. But if you're looking to be more accurate, you can use the actual XY when possible. But you have to be careful, because if you're plotting that, you might have a sounding, the minimum sounding might be right here, and then in the grid right here, there might be a minimum sounding here. Grid over here might be the minimum sounding in this corner, so they might actually overwrite. So it's something that you want to watch out for. Okay, a couple results, and let's run through it. Let me go into, I probably created a project, sample map. Okay. Here's a multi-beam data set. I think this was exported out to a 2x2, and I figured I'd use one that's slightly binned to save a little bit of time. But it works great with really large multi-beam data sets. Okay, so first thing you have to do is create a matrix file, and that's under the Preparation Editors Matrix Editor. Okay. I have one drawn on the screen here, but this works very similar to the plotting sheet editor, where you get a rectangle on the screen here. You take the lower left-hand corner, kind of position it, rotate with the opposite, and then you can use the other ends, the opposite ends, to change the length and width. And you see those changing in the box, as we see over here. I could go in here and enter cell length and width here. They don't have to be the same, so you might want to do, I don't know, a 10 by 20 grid for some reason. You know, sometimes that works out better for single beam because a lot of times, you know, you're going to have a you know, you're going to be a lot further apart with your lines than you would like multi-beam for complete coverage. So you can play around with that if you require it. I think that was all. Oh yeah, if you're not familiar with the matrix editor, there's a matrix type. For Mapper, it doesn't really matter. The only these options here are specific if you're using it in HYPACK survey, high sweep survey, or dredge pack. So nothing. It doesn't really matter which one you choose here when you're using Mapper. Okay. Since I created one, I've got it right here. Okay. So to run that, we'll go back under the processing menu again, sounding selection, and click on Mapper. We'll hit the open folder. This is, you'll see that I have the drop-down menu. I could bring, I have to load up a matrix first. And then the next thing is going to prompt me for my data. And if you hit the drop-down menu over here, you'll see you know, the different types. You have a log file, so again, that could be single beam or multi-beam log data, XYZ data, EDT files, which are our, you know, single beam edited files. Individually, you can bring those in if you want. Just individual the multi-beam files, matrix files. If you take a high density matrix, you want to make a lower density filled matrix, you can do that. So I think I have XYZ data here, and let me go to my sort folder. Here we go. It's a 2x2 file. So you'll see as I zoom in, you can see the 5x5 matrix that I created kind of blocks off everything here on the screen. But that's basically what I'm looking for is to grid my data. Okay, so I have a few different options in here by clicking on matrix. So some multiple sounding types for the matrix. I can say minimum or average. I'm not even sure what the channel stuff is. Oh, I could save, you know, the minimum or maximum or average above or below channel and so on. So there's a few different options of ways of saving data. The other option here, the main one that we saw before, the sounding grid. So in this case, I'll just choose nearest to cell center, make a nice pretty matrix here. And then I'll, in the example here, I'll just use the cell center XY. Actually, I'll try, yeah, I'll just do it that way right now. Click OK. Didn't see much of a change here. And then I have the option, again, I can save out, if I move this out to a filled matrix or to an XYZ file. So let's just call this one again, nearest. And let me go back here, and I'll also go, let's do a minimum sounding, and we'll use actual XY. And click OK. See a whole, you're not going to see a whole lot change here unless you do something like strike this, but I'll show that in a little bit also. So let's go save to XYZ, and we'll call this one min. So we zoom in on an area over here, and let me just change my sounding style to decimal point on mark. Keep zooming in. So we got a pretty dense, this is a 2x2 data set. Let me disable that. Okay, and start with my nearest to cell center. So you see I've got a nice even grid over here. And you see the grid is based on the rotation of my matrix. Okay. Now if I look at the minimum, you'll see that they're a bit scattered, and you'll see that, you know, the reason being again is with the matrix file, you know, they're all probably around the same relative area. So if that's the case, you know, you might, and you're looking for the minimum sounding, and you want to plot it, you might want to choose a cell center, or move to cell center basically. So those are different mapper options. Okay. I mentioned about the strikes. Basically, a strike is, yeah, like it says here, defined as the height of the bottom above a user-defined level. So if I had a strike depth of, of 12, and I had a sounding that's at 10.6, the strike depth would be, or the strike output would be 1.4, just telling me it's 1.4 above that strike depth. So I can output strikes out of the so if I have a specific channel depth that I want to use, I can get an idea of the soundings, you know, and their height above the bottom. Okay. Any questions on Mapper?
You had a box on there, a couple of check boxes on there that had, I think it said remove above, or remove below.
Oh, was that other window that we had open?
Yeah, can you set like a depth that it just ignores those?
Let's see. So go back in there. Let's see if I can find that. That was under here?
Yeah.
Oh, okay.
Yeah.
Yeah. So, yeah.
Put a depth there that you want to ignore above.
Exactly, yeah. If I had a channel depth at 20, I want to remove everything below. I can just put 20 in there. It'll just ignore everything under 20.
Does that affect like an average in the cell?
I would assume it would.
Would it sort the average after you remove those?
You know, actually, it probably no. You know, it probably wouldn't affect the average now that I think about it, because it's just going to remove it from the final results. You know? So I think I believe it's going to be accounted for in the average. Mm-hmm. Yeah, let's just skip out on some of these options. Just have it, I guess.
I just saw them there, I was just going to, matter of the
Yeah. I don't believe it's going to affect your average or anything like that. So, okay. All right, and then the last thing is, it's not a sorting program, but it's kind of based on, because we do the cross sort and everything, is this program called Cross-Check Statistics, which is a stats program for single beam data. Okay. And what this program is doing, it's you're taking in your survey lines, your cross sectional lines, and also your longitudinal lines, your check lines, and it's computing the difference at the intersection locations, and it's giving you stats based on those. Again, it works with your edited single beam data. It's not going to work with multi-beam. Multi-beam has its own stats tools in NBMax. And you need to have cross-sectional data and longitudinal data. It could be in, I believe it doesn't matter, they don't have to be separate log files. I think you just take the entire data set in and it should work showing your intersections. So basically what it's doing, and it's kind of weird the way it works, I think they've been talking about changing it for years, but it hasn't happened. The lines actually require, when you survey them, actually HYPACK, planned lines. And it's using the planned line intersection, and then what you're doing is you're specifying a radius and looking for the soundings closest to that radius, and it's interpolating and calculating the difference there at the intersection. Okay. So to run that, this is actually under the utilities menu, and you go under the cross-check statistics. So let's run that. And going back to the other project, I think was projects, sample sounding selection. There we go. All right. So if I go under utilities, cross-check statistics. A little bit bigger. Click on the open folder. Got my, it's going to prompt me for the data. And I can do the stats based on depth 1 or depth 2 also. Click on add files. I'll just choose both. Yeah, you can choose multiple log files and everything is run in a large data set. It usually runs pretty quick. And then I have my search radius. So I'll just leave the 50-foot search radius in here. And again, it's just looking for the intersection within that 50-foot. Probably be nicer just to not be able to require a plan line and just look for the intersections. At some point, we'll probably add that to this program, have both options in there. Usually we make a change or something, probably for the better, but somebody gets teed off because it doesn't work the same anymore. So, damned if you do, damned if you don't. So right off the bat, when I load it, it's actually going to show all the intersection values, the differences at each intersection. And I can use my mouse to kind of rotate, zoom, get an idea of what these values are. And then down below, I've got all my stats over here. I've got the number of intersections, standard deviation, mean difference, arithmetic difference, min and max difference too. And then it basically displays all the different lines, the cross-sectional x and y values that are computed, the depth 1, depth 2, and the difference between all of them. Okay. We also have the histogram over here showing our differences on the screen here. And you could take this and you can just export it right out to. There's a couple options in here. Where's the button now? Oh, set camera position. Okay. Yeah, a couple zoom tools here, but the mouse usually works just as good. Hit the save button, and you'll see I can save an XLS file or an HTML file. I think I saved one of these already. Like that, and then I'll save the Excel file. Did I do that? I think I saved it. Let me just try that one more time. Yep, okay. Now I'll do it again. Okay. So if I go into my project folder, I should have the XLS file. And then you got your Excel spreadsheet with all this information right here. So add that to a report or something. So that's the cross-stats program. Let me just see if there's anything else in there. Okay, I think we ran all this. With a 50-foot radius, ignores any intersection outside of that radius that we put in there. Display of results, and just a couple of things to watch out for. Keep an eye out. Just a couple, rule of thumb: high mean difference, low standard deviation might be a systematic error. Low mean difference, high standard deviation, equal values in the check lines versus the mean difference, so they should average out pretty large differences in some intersections. Low mean difference, low standard deviation is what you want, and then high mean difference means that you got something really going on here, so you might have offsets wrong or something, heave issues or something like that. So pretty good, really good QC tool to use. Okay. A couple recommendations here. Run the first survey line twice. Again, that comes in handy. You just double check, make sure you don't have a latency issue, because that could be contributing to the issues. Run the channel center line and or some offsets to the center line. Okay, just for repeatability. And then run the last survey line. Same thing as just a double check on your latency. So I think we're good there. Any questions?
On the average reports in the cross section, take the radius and average every sum in there
For the cross stats?
Yeah.
No, it actually. Let me just disable the data here. Okay. It's looking for the intersection here. It just generates a radius around there, and it's looking for the closest. Probably display here on the screen anyway. That's not the one I want. Zoom in. Yeah. So if I had a 50-foot radius here, it's looking for the two closest soundings on each side of the intersection. It basically draws a line and interpolates, gets a depth right at the intersection, and it does the same on the opposite ends here.
Yep.
And then it finds the difference of those. So, okay. But yeah, for some reason, they use the plan lines in order to determine which intersections. I don't know why. You know, you should be able to get every intersection, to be honest. You know, but that's just the way it works. Like I said, we've been talking about changing that for a number of years, but you know, until somebody really requests it. So send in the emails, we'll get it done for you. Okay. Any questions?
Is your recommendation like run that first line twice? I talk about the same direction.
No, for latency, for single beam, you go in opposite directions. Yeah, yeah. Yeah. So, and then to do the same thing at the end also. Just it's a good test point. Just make sure that there are no issues or whatever, you know, in case you get some kind of lag on the computer or something that's slowing things down. You know, at the end of the survey, you know, at least you know when you're doing your cross-check lines. Well, I double check my latency again, make sure that all worked out okay. All right. Again, we have record time here. Thanks a lot for sticking around, and you know, you guys will be first in line. I'm up here if you have any questions. So, thanks.